Hi students, welcome to my lectures on chemical reaction engineering. In our previous class, we have discussed about the speed of a zero order reaction. If anybody is watching this lecture, please go back to my previous lecture and watch the zero order reaction. And in the same way, and today we are going to discuss about the speed or rate of first order reaction using integral method of analysis. Let us go to the board. And because it is a first order, the simple reaction we can assume is A gives rise to B, and rate minus A, rate of disappearance of A is equal to minus dCA by dt is equal to K times Ca. Earlier for the zero order reaction there is no Ca term. Here now the Ca power 1 term is there. Ca power 1 means first order reaction. And how to find out the units of the K is the rate constant. How to find out the units of the rate constant? Just we have discussed about the earlier class, just like the way we discussed about the last class. K is nothing but dCA by dt by Ca. What are the units of concentration? Mole per liter. What is unit of time? Which is minute. What is the moles of units of concentration? Mole per liter. Okay. This liter cancels, mole cancel, and you get per minute. That means the units of a rate constant for a first order reaction is 1 by time, which is minute. Okay. Let us go with the derivation. I know, let us keep the concentration terms on one side, time terms on the another side, and that means minus dCA by Ca is equal to K times dt. Now apply the limits. At time t equal to 0, concentration of A is the initial concentration. At time equal to t, the concentration is nothing but the Ca. That means t equal to 0, Ca equal to Ca0, t equal to t, Ca equal to Ca. And if you apply the limits as we have discussed and integration of 1 by x into dx is nothing but ln of x, that is minus ln Ca, and apply the limits Ca0 to Ca. Here integral 0 to t dt is nothing but t. Now apply the limits and minus ln Ca minus ln Ca0 is equal to K times t. Log A minus log B log A by B. It is minus ln Ca by C0 is equal to K times t. K is the first order rate constant. And if you imagine, it's a kind of equation of the line y equal to mx. That means y is nothing but minus ln Ca by Ca0 and x is nothing but time. That means if I plot, if this is a first order reaction, if I plot minus ln Ca by Ca0 on the y axis, time is on x axis, then I should get a straight line. Okay? Then whatever I have assumed is a first order reaction. Let us see, and if you somehow simplify the equation further, and if you take ln to this side, it becomes exponential. Okay, then final concentration is equal to initial concentration into exponent of minus kT. Earlier it is for a zero order reaction, it is a linear equation, and for the first order equation it is called exponential equation. That means there is no linear equation will come. Now the exponential drop is going to take place. So I have to prove that whatever the reaction I have assumed which is happening in this reactor is a first order reaction. If that is a first order reaction, I should get a linear line if I plot minus ln by Ca by Ca0 and time. Okay. Let us do that. There is some experiments I have conducted, example in a batch reactor. I have kept initial moles of A in the reactor is 50 mole per liter. Then at every 5 minutes I have taken the sample out from the reactor and find out the concentration of A. Of course, because of the reaction the concentration of A will drop. At 0 time the concentration of A in the reactor is the initial concentration with Ca equal to Ca0, and minus ln of Ca0 by Ca0 is nothing but 0. After 5 minutes the concentration I have found in the reactor is 30.3, and ln of Ca by Ca0 means ln of 30.3 by 50. Like that I have every time I have the concentrations in the reactor and I have found out minus ln by Ca0 at every time. Now what we have to do is I have to plot this and this, like ln Ca by Ca0 minus ln Ca by Ca0 on the y axis and the time is on x axis. Now you can see if I draw a straight line, I can connect all the points. That means whatever equation I have assumed based on the first order and whatever the experiments I have conducted, both are aligned on the same line. If they are aligned on the same line, where the r square value of the, I mean, if you plot an Excel, if you measure the correlation coefficient, I mean, r square value is more than 0.99%, I mean 0.99, then what I can say that experiments is also first order, my assumption of the model is also first order, then both are same, then I can say that the reaction is a first order reaction. Okay. Then whatever I slope, y equal to m into x, y is this, x is time and k is nothing but slope of the equation. The slope of the equation is nothing but first order rate constant, that is 0.1 per minute into 1 by minute. The units of the rate constant is by minute. And now nothing but Ca is equal to Ca0 into e power minus kt. I have already found what is k, it is nothing but 0.1. Earlier for the 0 order reaction, it is the slope, I mean the line is a straight line, the slope everywhere it is constant. Now for the first order reaction, because this is an exponential function, the concentration of A will drop exponentially. That means the slope of the line is higher at smaller time. As the reaction proceeds further, the slope is getting reduced. That means the slope is steeper at the beginning of the reaction, the slope is not steeper at the end of the reaction. That means towards the end of the reaction. Larger slope means the speed of the reaction is fast at the initial stage. Low slope means the speed of the reaction is slow at the towards the end of the reaction. Earlier for the 0 order reaction, the slope is constant everywhere. That means the speed at which the reaction is happening is the same whether you are talking about the beginning of the reaction or end of the reaction. Here the first order, because the exponential drop equation is there, the speed of the reaction is faster at the initial stage. That means when the concentration of A is more, the speed is more, the concentration of A is less, the speed is less. Now my speed depend on concentration at what power? Power 1, first order. That means this is what the important. So let us measure the speeds. Now you know the equation, let us measure the speeds, you will understand. So I know the time data and concentration data. Let us measure the speed of the reaction. Speed, that means rate of the reaction, is equal to minus dCA by dt is k times Ca. Okay. At the starting at 0 time, the concentration of A is initial concentration, which is 50 mole per liter. What is the speed? Is nothing but k times Ca. The k is nothing but I got from this equation 0.1 into this concentration, that is 5. That means the speed of the reaction is 5 mole per liter every minute. That means the concentration will drop to 5 mole per liter every minute. That means if you start at 50, every minute the concentration will drop to 5 mole per liter, that is 45 mole per liter, like that. At time after 5 minutes, what is the concentration in the reactor? Is nothing but 30.3. But after 5 minutes, what is the speed of the reaction? Is nothing but 0.1 into 30.3, which is 3. That means you can see speed of the reaction is getting reduced with the time. Okay, I mean reduced with concentration. That is, more is the concentration, more is the speed. Less is the concentration, less is the speed. This is what the typical difference between 0 order and first order. Okay, that means now the speed depends on concentration. Earlier for the 0 order, whatever may be the concentration, the speed is constant. Here the speed of the reaction depends on the concentration. Higher is the concentration, higher is the speed, lower is the concentration, lower is the speed. This is what the thing you have to absorb in your mind. Okay, let us go back to the next stage, which is called the conversion. Here we have discussed everything in terms of concentration. Here we have discussed everything in terms of conversion. I know Ca by C is equal to e power minus k into t. Okay. Now let us reformulate this equation into conversion. I know Ca0 minus Ca by Ca0 equal to Xa. 1 minus Ca by Ca0 is equal to, I mean minus Xa, okay. Then what is Ca by Ca0 is nothing but 1 minus Xa. Simply I will replace the Ca by Ca0 with 1 minus Xa, that is 1 minus Xa is equal to e power minus e minus k into t, and if I apply ln on both the sides, minus ln into 1 minus x is equal to kt. Now here you can see the linear equation. Y is nothing but minus ln of 1 minus xa, x is nothing but time. That means if I plot on the y axis minus ln of 1 minus xa and time on x axis, I should see the straight line. It is the same thing, one is in terms of concentrations, another thing in terms of conversions. Hope you understand the difference between the 0 order and first order. Let us meet with the new lecture. Thank you.